Okay, so this is a bit of an aside here to talk about limits when you've got numbers, specifically fractions to the nth power. So if you've got a fraction to the nth power and that number is between 1 and -1, or absolute value smaller than 1, then that limit will equal 0. If the number k is bigger than 1, absolute value is bigger than 1, then that limit will equal infinity. So that comes into play when we're doing limits of these kind of things. So here I have 3/4 to the n. So here k is equal to 3/4, so that gets us in this category, right? Absolute value of k is smaller than or equal to 1, so then that limit is 0. So then therefore I can say it converges. Now I have to the n plus 1. All right, so let's just kind of play with it a little bit. Limit as n goes to infinity. So I have -3/2 to the n times -3/2 to the 1, right? Because I would be adding exponents. So this is me just pulling this off to the side so that I can just look at what the number to the nth power is to decide if it converges or diverges. So what I can think about doing is taking that -3/2 outside. Okay, so -3/2 to the nth power, so my k is -3/2. That gets us to this situation, and so this limit is infinity, and so then it diverges. This one here, a little bit of work needs to be done, so just a little bit of exponent work. I'm always going to suggest that you put the negative exponents in the denominator, and then I'm going to take another step and make it a number to the nth power. So I have 4/25 all to the nth power. So here my k is 4/25, so that gets us in this situation, and so I can see that the limit is 0, so it converges. All right, just continuing on with converge or diverge is the question. If it's convergent, find its limit. And I'm just giving you a little bit of a heads up here. If you're going to use L'Hopital's rule, you have to change it to x's. So if I try to take the limit as n goes to infinity, ln of n cubed over n squared, I do get infinity over infinity. I cannot do highest powers on this. So what I'm going to do is I'm first going to use the properties that I know about ln and bring this 3 down in the front. This is not a derivative, this is just using the properties of ln. All right, so now I'm going to use L'Hopital's rule, so I'm changing it to x's as I do it. Right, got to change it to x's if I'm going to use L'Hopital's because I have infinity over infinity. So then I'm going to carry the limit along. So I get 3/2x squared. Now let x go to infinity. That gives me 0. Converges. All right. Limit as x, or I'm sorry, this starting it off as n going to infinity, n sine of 1/n. So if I plug in infinity, I get infinity times 0. Yes. We remember this. We want to get it ready to do L'Hopital, so I'm going to change it to x's, and I want to move one of them to the denominator. Always choose the easier one, so I'm going to leave sine in the numerator and move n, or x, to the denominator as 1/x. Now it's ready to take the do L'Hopital's, right? If I plug in infinity, I get 0. Sine of 0 is 0. 1/infinity, 0. So doing L'Hopital, I get cosine of 1/x, derivative of 1/x, -1/x squared, -1/x squared. So you can see these two things will cancel. So what I'm left with is cosine of 1/x. So now evaluate it, put in infinity, I get 0 inside of cosine. Cosine of 0 is 1, so it converges to 1. Limit as n goes to infinity, n e to the -n, so this would give me infinity times e to the -infinity, that would give me 0. Okay, yet another I have to do a L'Hopital, so I want to put one of them in the denominator, changing it to x's. So I'm going to put the e in the denominator because that e term will go in the denominator as just e to the positive x. So it's infinity over infinity, ready to go for L'Hopital. So I get 1 over e to the x. Now evaluated at infinity, I get 0. So it converges.